Welcome to the Introduction to Geometry. In this lesson, we will define geometry, talk about its essential principles, and provide examples to illustrate those principles. Now, geometry is a branch of mathematics that deals with the physical and theoretical properties of figures and shapes and its application to the real world. Now, geometry can be studied in an informal way using intuition, or perhaps a more formal way with deductions, definitions, and proofs. Now, geometry does have some essential building blocks behind it. The first one is an axiom. An axiom is a statement about quantities in general accepted without proof. Now, more specific to geometry, we discuss postulates, which is a statement accepted without proof that applies to geometry. But let's talk about axioms first. So let's discuss it with a basic example. So, if 6 is equal to 4 plus 2, and 6 is also equal to 5 plus 1, then we can logically conclude that 4 plus 2 is equal to 5 plus 1. Because 6 was equal to 4 plus 2 and equal to 5 plus 1, those two quantities are equal to each other. We describe this also as a transitive property of equality. Now let's take a look at a postulate. And to investigate a postulate, let's go ahead and draw a circle. And that circle is, of course, going to have a center. And I imagine that this circle with center A has a radius that extends from a point on that circle, point B. And that radius from the center to the point has a measure of 7 centimeters. I can draw another point, point T, and another radius from point A to point T will also be 7. And another point on the circle, point D, when drawn a line from D to A, will also have a length of 7 centimeters. Now, from this observation, I can conclude that every point on a circle is equidistant from the center of that circle. All these points are being on the circle, and they all create a radius from the center. The biggest thing between axioms and postulates is that we can make conclusions about other items. Let's look at another example with a circle. P is at the center of this particular circle, and the radius of this particular circle happens to be 8 inches. So I draw this radius and I label it with 8. So now I get another item where point R is 5 inches away from P. So point R is somewhere here, and it's got a length of 5 inches away from P. Now, because the radius is 8 and point R is only 5 away, we can conclude that R is not on the circle. Any point on the circle will be 8 inches away and not 5 inches, the length that R is away from the center of our circle P. Let's look at another example. Let's say that I have two lines, lines J and line K. I'll go ahead and draw the arrows on these two lines. And I'm going to say that these two lines are parallel, so that these two lines will never intersect. I have a third line now, line M, and let's say that line M is parallel to line K. So line M is parallel to K. Well, because M is parallel to K and K is parallel to J, I can conclude that line M is also parallel to J. So with some basic rules and some applied logic, we are then later able to incorporate more information and solve bigger problems.